So in a previous video, we talked about factoring expressions from a quadratic standpoint when a was 1. Now let's look at things that are a little bit more challenging. So again, let's remember factoring is to break something down to smaller pieces. And when we talk about factoring in math, we're talking about quadratic expressions when a is greater than 1. And again, our goal for the day is to break these expressions down into their smaller pieces by factoring, and we're going to do that by the area model. Okay, so again, here is the area model. Let's take example 1. Factor the quadratic expression 3r squared minus 11r minus 4. Okay, when we talk about the area model, we need to make our squares. Now, let's go ahead and break this down like we did in the previous video. Again, the first thing I want to do is take that first term, that 3r squared, and I'm going to put it in the upper left-hand corner of the boxes. Then I'm going to take the constant term, or the only number up there that doesn't have a variable behind it, the negative 4, and I'm going to place it in the bottom right-hand corner. Now here's where it gets a little trickier than last time. I can't just take the negative 4 and find numbers to multiply by it in order to get negative 11 with adding or subtracting. Here is what I'm going to do. I'm going to take that a term, 3, and the c term, negative 4, multiply them together. So for every time we have a value that's in front here, in this case it's 3, I'm going to multiply that number times the constant. And I'll get a negative 12, and again I'm going to write that off to the side. Now that's the number I'm going to use to try to find factors of in order to use them for the negative 11 with addition or subtraction. So I'm trying to find numbers that I can multiply to get to negative 12 that I could manipulate in any way with plus or minus signs to get negative 11. So I can go down the list here. 1 times 12, 2 times 6, or 3 times 4. So which one of those pairs works best for me here? Again, I'm trying to take one of those pairs and manipulate them through addition or subtraction to get negative 11. And the answer is going to be a 1 and a 12. Now, how do I manipulate the signs? Well, if I'm trying to add or subtract to get negative 11, the 12 is going to have that minus sign, and the 1 will have the plus. So I'm going to have a plus 1 and a minus 12, and that's what I'm looking for. So again, just like in the previous video, I don't care the order of how we put them into the boxes. I just need to make sure that I put them with the correct signs, and I also need to make sure that I put the r behind both of them. So for this one, I'm going to put 1r, and I'll put negative 12r. Okay. Now we're going to find the greatest common factors of each pair. So let's start with the 3r squared and the 1r. What is the greatest common factor of these two terms? Meaning, what's the number I can pull out, or what's the thing that I can pull out of both? R is the only thing that I'm able to pull out because that's the only thing they share. So on top of my box, I'm going to put an r. Same thing with the negative 12r and negative 4. The only thing that I can divide out evenly or factor out evenly of both of those terms is a 4. Now remember, when this term or this term has a negative in front, the negative has to come with it. So I'm going to put a negative 4 here. Now we'll do the other side. What's the common factor between 3r squared and negative 12r? That's going to be 3r. And what is the common factor between 1r and negative 4? And 1 is the only thing I can pull out of there. And I have got my factors. Just like in the previous video, my factors are r minus 4 and 3r plus 1. Final answer. Let's try the next example together. 10a squared plus 11a plus 3. Again, let's make our boxes and let's fill in what we know. 10a squared is going to go in this first corner box here. Positive 3 is going to go in the bottom right. Now again, I need to find an 11 with manipulation a little bit here. But I'm going to multiply the 10 times the positive 3, and that's going to give me 30. So I'm trying to find factors of 30 that I could use to manipulate to get 11 with addition or subtraction. So I've got 1 times 30. That doesn't look like it's going to be it. 2 times 15. 3 times 10. 4 doesn't work, so we'll jump to 5 and 6, which happens to be the pair that I need. Now, because I need a positive 11, I'm going to get really lucky here. It's going to be a plus 5 and a plus 6. And those are going to be the two numbers that I plug into my boxes here. So again, it doesn't matter the order of that. I'll put the 5a here, and I'll put the 6a here. Okay, greatest common factor time. 10a squared and 5a. 5a is the greatest common factor. That can come out. 6a and 3. Greatest common factor there is just a 3. Off to the side now, 10a squared and 6a. Greatest common factor here is going to be 2a. And then with the 5a and the 3, they don't have anything in common. And that's going to happen sometimes that we go through these process. We're going to just make that a 1 if there isn't anything else that we can take out. So 1 is going to be my greatest common factor there. And I've got my factors. So the answer, when I ask you to factor this quadratic expression, it's going to be 5a plus 3 and 2a plus 1. All right, everyone, so just like last video, I want you to try one on your own. This time I'm just going to kind of cut to the answer. And that didn't work out how I wanted it to, I don't think. That's okay. So if you got your factors 2k plus 1 and k minus 4, you're looking good. That's a wrap for there. Things to remember for this video. Exactly the same process as the last video. The only thing that's going to be different here is our coefficient. Our initial terms coefficient is going to be a number that's greater than 1. Now, as we saw from today's video, it could be 2, 5, 3, 10, whatever. It doesn't matter because the area model still helps us through that process. See you next time.